Hello, my dear students. How are you all? I am fine. I am Khandekar Fazle Rabbi, lecturer, Department of Chemistry, Milestone College, Uttara. During this pandemic situation, welcome you all to our online chemistry class. My dear students, today we discuss about some important MCQ from chemistry second paper Chapter 1 Environmental Chemistry. My dear students, this is our first MCQ. Which of the following gaseous law is followed by the following graph? So, we see the graph in x-axis here given the value of P represent pressure, and in y-axis here given the value of PV, here V represent volume. So, the answer may be Avogadro's law, Graham's law, Charles' law or Boyle's law. My dear students, according to Boyle's law, we know that P1 V1 equal to P2 V2 equal to P3 V3. So, if P1 equal to 1 and V1 equal to 60, then P1 V1 equal to 60. If P2 equal to 2, then V2 equal to 30 and we get P2 V2 equal to 60. And if P3 equal to 3, V3 equal to 2, then P3 V3 equal to 60. So, we see that P1 V1 equal to P2 V2 equal to P3 V3 equal to K, that is constant. Now, if we see if P equal to 1, then PV equal to 60, that means P1 V1 equal to 60. If P2 equal to 2, that means P equal to 2, then PV equal to 60. P equal to 3, then PV equal to 60. So, we can say that this graph follows Boyle's law. So, the answer is Boyle's law. My dear students, this is our second MCQ. Here given the graph in x-axis, here given liter, that means in x-axis we use here volume, and in y-axis here given atmosphere, this is the value of P. So, in this graph here given 2 point, this one and this one, and question is, according to the graph, which one is the value of V? So, if we discuss about this point, this is the value of P equal to 1.2 and value of V equal to V. And for this point, the value of P1 equal to 0.5 and value of V1 equal to 0.3. V1 equal to 0.3. And my dear students, we know that according to Boyle's law, PV equal to P1 V1. So, the value of P equal to 1.2 into V equal to P1 equal to 0.5 into V1 equal to 0.3. So, the value of V equal to 0.5 into 0.3 divided by 1.2, and answer is 0.125. So, we can say that the answer is 0.125. This is our third question. From the combined formula of Boyle, Charles and Avogadro's law, the equation of density of gas is D equal to A, option A, D equal to Pm by RT, option B, D equal to RT by Pm, option C, D equal to Pm by RT, and option D, D equal to RT by Pm. My dear students, from the combined law, we know that PV equal to nRT and PV equal to M by M RT. So, Pm equal to M by V RT, and we know that density D equal to M by V. So, we can write here Pm equal to dRT. So, D equal to Pm by RT. This is the correct answer. And so, we can write here. That means C is the correct answer. D equal to Pm by RT. Our fourth question, which is the ideal gas equation for 44 gram carbon dioxide? We know that 1 mole carbon dioxide equal to 44 gram. So, for carbon dioxide 1 mole, N equal to 1, and ideal gas equation is PV equal to nRT. If we write the value of N equal to 1, then we get PV equal to 1 into RT. That means PV equal to RT. And for this case, we can write the answer is A, PV equal to RT. This is our fifth question. The density of a gas is 2.25 gram per liter at 18 degree centigrade temperature and 0.8 atmosphere pressure. What is the molecular mass of that gas? My dear students, here given the density, and we know the formula of density D equal to Pm by RT. So, we can write M equal to dRT by P, and here given density is 2.25, and temperature, molar gas constant R equal to 0.0821 into temperature T equal to 18 degree centigrade, that means 291 Kelvin, and pressure P equal to 0.8, and we get the answer 67.11. So, for this question, the answer is A, 67.11. Now, question number 6. 3.2 gram of a gas occupies 2.24 liter at STP. The gas may be carbon monoxide, carbon dioxide, nitrogen, or oxygen. We know that M equal to mRT divided by PV. M equal to mRT by PV. Here small m, mass of the gas. So here we write 3.2 molar gas constant R equal to 0.0821, and T, temperature T, here given STP in the question, here given STP, so the temperature is 0 degree centigrade, that means 273 Kelvin, and at STP pressure P equal to 1 atmosphere and given volume is 2.24 liter, and we get the answer is 32. We know that the molecular mass of oxygen is 32 gram. So the answer is D. Our next question, what is the molar volume of any gas at SATP? We know that at SATP the volume of any gas is 24.789, and we get the answer here, option D. Next, value of Boltzmann constant at SI unit is option A 6.023 into 10 to the power 23, option B 6.02 into 10 to the power minus 23, option C 1.38 into 10 to the power minus 23, and option D 1.36 into 10 to the power minus 25. My dear students, we know that Boltzmann constant K equal to molar gas constant R divided by Na. So K equal to in SI unit we get R equal to 8.314 divided by Avogadro's number 6.023 into 10 to the power 23, and the answer is here K 1.38 into 10 to the power minus 23. So here the right answer is option C, 1.38 into 10 to the power minus 23. Okay, our next question, 0.5 mole of nitrogen and 0.3 mole of oxygen are mixed together. What is the mole fraction of oxygen? So my dear students, mole fraction of oxygen equal to mole number of oxygen divided by total mole number. That means mole number of oxygen equal to 0.3 divided by 0.3 plus 0.5, and the answer is 0.375. So option D is the correct answer. Our next question is 6 mole oxygen and 14 mole nitrogen are mixed together. The pressure of the mixture corresponds to 200 millimeter. What is the partial pressure of oxygen? We know that partial pressure equal to mole fraction into total pressure. So partial pressure of oxygen PO2 equal to mole fraction of oxygen, that is mole number of oxygen divided by total mole number 6 plus 14 into total pressure, that is 200 equal to 60 millimeter, and answer is option C, 60 millimeter. Next question, question number 11. Which one is Graham's diffusion law? My dear students, we know that Graham's diffusion law is R is proportional to 1 by root over m, or R1 by R2 equal to root over M2 by M1. So we can write here R1 root over M1 equal to R2 root over M2, and for this case the answer is option A. Now question number 12. Which two gases have same diffusion rate? My dear students, according to Graham's diffusion law, we know that the rate of diffusion of gases is inversely proportional to the square roots of its density or molecular mass. That means if two gases have same molecular mass, that means that gases have same diffusion rate. Now the molecular mass of nitrogen is 28, carbon monoxide 12 plus 16, 28. This for here 12 into 2, 24 plus 4, 28, carbon 24, nitrogen 28, oxygen 32, carbon monoxide 12 plus 16, that means 28, and for oxygen here 32. So the correct answer is option A. Now question number 13. At 27 degrees centigrade, what is the RMS velocity? What is RMS velocity of oxygen? My dear students, RMS velocity, that means root mean square velocity of oxygen. We know that C equal to 3 RT by M root over. That means C equal to root over 3 RT by M. So here we write 3 into molar gas constant R equal to 8.314 into temperature given 27 degrees centigrade, that means 300 Kelvin, and molecular mass of oxygen 32. Here we use SI unit for R. So molecular mass of oxygen is 32 into 10 to the power minus 3, and we get the answer is 483.56. So we can say that the correct answer is option D. My dear students, here question number 14. What is the correct order of gases in respect of RMS velocity at constant temperature? Okay, my dear students, we know that RMS velocity C equal to root over 3 RT by M. Here given the temperature is constant, so for this case RMS velocity is inversely proportional to the square root of molecular mass. That means if the molecular mass is small, then the RMS velocity is higher. So according to our discussion, we can say that the correct order of gases in respect of RMS velocity is option A, because the molecular mass of hydrogen is lower than nitrogen and molecular mass of nitrogen is lower than carbon dioxide. Our next question, which is the kinetic energy of 1 mole of gas? My dear students, we know that kinetic energy Ek equal to 3 by 2 nRT. 3 by 2 nRT. If we use here 1 mole gas, then n equal to 1. So the equation stands here option D, because if n equal to 1, then we get Ek equal to 3 by 2 RT. Our next question, question number 16. What is the kinetic energy of 3 gram nitrogen at 302 Kelvin? My dear students, we know that kinetic energy Ek equal to 3 by 2 nRT, and again 3 by 2 n equal to m by m RT. Here small m is the given mass of nitrogen and m represent the molecular mass of nitrogen, and we get here 3 by 2, given mass of nitrogen is 3 divided by molecular mass of nitrogen, that is 28, and molar gas constant R equal to 8.314 into temperature 302 Kelvin, and we get the answer is 403.52 joule. So according to this mathematical problem, we can say that the correct option is A, 403 joule. My dear students, now question number 17. Which one is the van der Waals equation for 28 gram nitrogen? We know that van der Waals equation is P plus n square A divided by V square V minus NB equal to nRT. My dear students, for 1 mole nitrogen, that is 28 gram. Okay, 1 mole nitrogen equal to 28 gram. So here n equal to 1, and for this case we can write P plus 1 square A divided by V square V minus 1 into B equal to 1 into RT. So we get P plus A by V square V minus B equal to RT. So the correct answer is option C. Now question number 18. What is the coefficient of compression of ideal gas? That means Z equal to what? We know that for ideal gas the coefficient of compression is 1. So the option is C, and the correct answer is C. Our next question, question number 19. To increase the temperature of atmosphere, rule of which gas is maximum? That means which greenhouse gas increase the temperature of atmosphere maximum? That is carbon dioxide. That means option A is correct. And our next question, question number 20. In which condition a real gas behaves like an ideal gas? And here option A, at high temperature and low pressure, option B, at high temperature and high pressure, option C, at low temperature and high pressure, and option D, at low temperature and low pressure. And the correct option is option A, at high temperature and low pressure.